Hi everyone, I welcome you all to the official YouTube channel of Chandigarh Career Group. Guys, my name is Abhishek and today is the last video of this ongoing series of practice questions of physics for upcoming NDA as well as CDS exam. So the topic that I have decided to discuss in the today's class is modern physics. It includes atoms and nuclei, dual nature of radiation. ठीक है, so let's start without any delay. And here comes the question number 1. There are two sources of light, each emitting with a power of 100 watt. One emit X-ray wavelength 1 nanometer, another visible light of 500 nanometer. The ratio of number of photons of X-ray to the photons of visible light of given wavelength is, first of all, it is photon, not proton, it's photon. So basically energy N1 hc upon lambda 1 is equals to N2 hc upon lambda 2. N1 hc upon lambda 1 is equals to N2 hc upon lambda 2. This hc will get cancelled, so N1 upon lambda 1, N2 upon lambda 2. So I want to calculate N1 upon N2. This will be lambda 1 upon lambda 2. Now see, lambda 1 is what? It is 1 nanometer and lambda 2 is 500. So ratio is 1 ratio 500. Option number A. Question number 2. वेव थ्योरी कैन नॉट एक्सप्लेन द फिनोमिना ऑफ. इनमें से कौन सा फिनोमिना है जो वेव थ्योरी एक्सप्लेन नहीं कर पाई है? सो दैट इज सी एंड डी, बिकॉज Compton effect as well as photoelectric effect both are explained by the particle nature. So that's why. In photoelectric emission, the number of photoelectrons emitted per second. See, there is a photoelectric emission and number of photoelectrons emitted per second depends on. ठीक है जी, फोटोइलेक्ट्रिक उसमें कितने फोटो इलेक्ट्रॉन्स पर सेकेंड जो है एमिट हो रहे हैं वो किस चीज पे डिपेंड करता है? फर्स्ट ऑप्शन है वेवलेंथ, सेकंड फ्रीक्वेंसी, तीसरा इंटेंसिटी, चौथा वर्क फंक्शन. वन बाय वन बात करते हैं. वेवलेंथ ऑफ इंसिडेंट लाइट ओनली matters if, like, we want to find out whether it is the sufficient amount of wavelength which is required to emit the electrons. So that will not determine whether how much electrons are emitted or not. Frequency only enhance the energy. It has nothing to do with number of photoelectrons. So that is also not correct. Intensity is the correct option. Work function is minimum energy required for the emission. So it's intensity. It is intensity of incident light that matters. Next question. The deflection of alpha particle through a thin foil is due to. जो अल्फा पार्टिकल डिफ्लेक्ट हो रहे थे थिन फॉइल से वो क्यों हो रहे थे रदरफोर्ड अल्फा पार्टिकल एक्सपेरिमेंट में? दैट इज रिपल्शन बाय न्यूक्लियस. न्यूक्लियस की वजह से रिपल्शन बाय न्यूक्लियस, न्यूक्लियस की वजह से. ठीक है, चलिए जी. नेक्स्ट. For nuclear forces to be effective, the minimum distance should be. Nuclear forces are effective within the range of nucleus. That is 10 raised to the power minus 15 meter, or else I call it as 1 Fermi. Next, which of the following transition in hydrogen? Which of the following transition in hydrogen gives an absorption line of highest frequency? So you can see 1, 2, 3. Absorption. Absorption means from low energy level to high energy level. Absorption. So this is N is equals to and N2 and N1. The requirement is N1 should be less than N2. So let's eliminate. This is not correct. This is not correct. Either this and this. So always remember highest frequency means maximum gap. So 1 2 3, 1 2 3. A metal surface eject electrons when hit by green light, but none when hit by yellow light. The electron will be ejected when the surface is hit by. जब ग्रीन लाइट ने हिट किया तो इलेक्ट्रॉन जो है एमिट हुए, और जब येलो ने किया तो इलेक्ट्रॉन एमिट नहीं हुए। ठीक है जी। तो यहां पर देखिए, सबसे पहले तो आपको विबग्योर और पता होना चाहिए। येलो से एमिट नहीं हो रहे, ठीक है। ग्रीन ने किया तो एमिट हुए, तो ये येलो से थोड़ा नीचे आना पड़ेगा। अब ऑरेंज भी ऊपर है, और रेड भी ऊपर है, इंफ्रारेड भी ऊपर है, तो ब्लू लाइट आएगा। इट्स ब्लू।